I'm a hydrogeologist. My motto in life is think out of the box. My name, Marcel. My experience, groundwater and soil contaminations. I'm the creator of Geo RGB, a channel of geographic information systems, GIS, geology, hydrogeology, and contamination. The purpose, the objective, the goal, the intention, the target, the desire. Share my experience and acknowledge to create points of discussion. The Geo RGB community. Promote the use of free and open source software. A free digital society. Provide technical advice to environmental companies. An opportunity for professional growth.
Hello guys and welcome back to my channel. In this occasion I'm presenting the tutorial related to soil sampling techniques using QuantumGIS. In this tutorial we are going to learn how we can use QuantumGIS to create a sampling campaign for contaminated soils. We are going to see some of the algorithms that QuantumGIS can offer us to simplify the mathematical part of the probabilistic sample techniques. This first tutorial is going to be an introduction where we are going to see some of the elemental definitions about the population, the sample, and the type of sample techniques. Also, we are going to select a real site, download the satellite image, and create some vectorial layers. At the end, we are going to discuss the importance of the spatial component in soil sampling. Let's go to do it. Today we are located in one of the biggest oil fields in the USA, located at the state of North Dakota. I took one of these fields to do the lesson for today. However, the data that I am going to use is not related with this field. It is even not real. I like to work with real sites to provide a more realistic scenarios and produce maps that can be examples for your projects. The use of real locations helps to have a better understanding on the analysis of spatial data and helps to elaborate better map compositions. To start today, let's go to see some elemental definitions. First, let's go to talk about the statistical population. In statistics, a population is a set of similar items or events which is of interest for some questions or experiment. Also, other important concept is related with the sample in statistics. In statistics and quantitative research methodology, a sample is a set of individuals or objects collected or selected from a statistical population by a defined procedure. Then we can say the sampling method involves taking a representative selection of the population and using the data collected as a research information. There are two types of sampling: probability sampling and non-probability sampling. Probability sampling is defined as a sampling technique in which the research chooses samples from a population using a method based on the theory of the probability. In this case, each member of the population has equal chance of being selected. Examples are random sampling, systematic sampling, stratified sampling, and cluster sampling. Non-probability sampling is defined as a technique in which the research chooses samples from a population using a method based on the subjective judgment. Members of the population are selected in non-random way. Examples are convenience sampling, judgment sampling, quota sampling, and snowball sampling. In this tutorial, we are going to talk about the random sampling, systematic sampling, stratified sampling, cluster sampling, and convenient sampling. Now it's time to start to work with QuantumGIS. I already opened my session. What I'm going to do now is load the satellite image. I am going to use the Quick Map Services plugin, and I'm going to use a Google satellite image. Then I'm going to select this option, and I'm going to open also the hybrid map to have a better reference to locate my site. This map over here. Then I'm going to make zoom. I'm going to take this one out. As we know, our site is located at North Dakota. And if you are using just the satellite image, you are not going to see these labels. Okay. As you can see now, that's the reason because I'm using the hybrid map to locate the site. I know my site is located in this lake, and this is the area I'm interested. And my site is located right here. Is this site over here. Now the next step is select the coordinate reference systems you want for your project. As we saw here with Google Earth, the site is located at the UTM Zone 13, as you can see here at the bottom. If you cannot see the UTM coordinates here, just go here to Tools, Options, and then select here Universal Transverse Mercator. Now we have to select that coordinate systems, then click here, this option over here, and it's going to be this one. WGS 84 UTM Zone 13 North. As you can see, that's the area for these coordinate reference systems. Then apply. Okay, and now we are ready to export the image. To export the image, I'm going to use the Google satellite image because I believe that one has a better resolution. Then I'm going to make a little bit of zoom, and I'm going to select the area I want to download. Then go here to Raster Tools and select the first option, Convert Map to Raster. Double click, select the area. It's going to be something like that, for example. The first option is good. And the second option is the resolution you want for your map. I'm going to take 0.1. If you want a better resolution, you can put a small number here, but this number is pretty good. It depends what is the resolution of the satellite image, right? As bigger is the resolution, you can put a smaller number here. And then let's go to save this image. Here as an image. Save and run. Close, and as you can see, we can take this image. That's our satellite image. Okay, that's good. To do all this process, we need internet connection because we are working with Quick Map Services, and this one is a server where you are going to download the maps. But once you have the image downloaded, you don't need to use internet. You have already the image in your computer, and also this image is georeference. As you can see here at the information, we have the coordinate reference systems over here. In order to define properly what is our population in our site for the samples we are going to take, it is very important to know what is the limits, the borders of our site. In this case, I am going to assume that I have the coordinates for the list, and I'm going to load that information. First, I'm going to show you the file. It's a file like an Excel file. It's an spreadsheet where the format is CSV. I'm going to open and show you how the spreadsheet looks like. It's this one here. As you can see, I put X, Y, and for each corner of the list, I put the coordinates. And these coordinates are going to make a shape of a perfect square. And I'm going to close this one here, go to Quantum GIS, go to this option here, then select this option, delimited test, then select your file. It's over here, project, this one, okay. Then make sure you have selected this option. Then the rest is okay. Here you have to select the columns where you have the X and Y and select the coordinate systems you want to use. It's this one, and then add. As you can see, we can see the coordinates over here. And close. Now we have the coordinates over there with the points, and I'm going to change the color to see more clear for a red one. Apply, okay. And now the next step is click right on your mouse and make sure you have this option, the snapping tool, already activated. Then you have to click on this icon over here to make sure the snapping tool works. The next step is just create a new shapefile layer. It's going to be the list of our site. I'm going to save in this folder as a list. Save, and it's going to be a polygon. And the reference coordinate systems is going to be this one. For the rest of these options are okay. Then we have this layer over here. Press the pencil to edit the layer, and we are going to make a square with these 4 points. Then go here, select the third option. As we have the snacking tools activated, when you put the mouse on the point, it's going to be that pink square. Then select this point, select the other point, go down and select the third point. Then click right on your mouse and put an ID over here, for example 1, and OK, and we have already the list. Then I'm going to close the edition, save, and I'm going to edit this one a little bit, properties, this one, I'm going to make this one transparent, and with a blue color and 0.5 over here, and also the kind of line is going to be a dashed line. Apply and OK. The dimensions of the square is 100 by 100. I made something easy just to avoid complications with the shape of the list, but it could be any shape. Then we can take this one out at the moment. Now we have the limits of our site and we are ready to define our population. The population is the potential samples that we can take. It means that we are not going to take all the population. What we want to take is just a small part of the population that is going to be representative of all population. Then my first approximation is to consider how many potential samples I can take from my site. Then at the beginning I'm going to tell you that maybe we can take one sample every 0.5 meters. I believe this distance is enough to avoid any cross-contamination between the samples. With 0.5 meters of distance, you can take a sample with a shovel, with hand auger, and also depending on the drilling machine, you can make a borehole every 0.5 meters. But as I said, that is the first approximation. We are going to talk more about this topic later. Then to show you the population, what I'm going to do is a grid of this area. To do that one, just go here to the option. I'm going to close this option, then go to vector creation. What we are going to do is create a grid. Double click on this option. Then here for the grid type, we are going to select rectangle. Then for the extension, we are going to use the list we created. For the horizontal spacing is going to be 0.5, and also for the vertical one, it's not going to be overlay, and the coordinate reference distance is good, and we are going to save this one. In this folder is going to be grid 0.5. Save and run. Close, and let's go to edit this one, properties, and let's go to make this one transparent, and that's good. Okay, now let's go to place each member of the population inside the grid. To do that one, just go here, regular points, double click, select the extension. The extension is going to be the grid for 0.5 meters, this one. Okay, then the point sparsing is going to be 0.5. that's the distance between each point or each member of the population, and here the initial inset from corner is going to be 0.25. Then the coordinate distance, the coordinate reference distance is good, and we are going to save this one here, but we are going to add here as a point. Then save and run. Close, and as you can see here, for 1 square meter we have 4 samples. Let's go to save the project, save as. Here is going to be sampling, save, and I'm going to take this one out, the image, and as you can see, this one it's a lot of samples, right? In total for this area we can go to the attribute table, move over here. As you can see, we have the numbers over there. In total it's 40,000. Then we can consider that for a list that is 100 by 100, and we are taking a potential samples every 0.5 meters. In this area we have a population of 40,000 different units, and at this point we have to ask ourselves, that is the real population of this site for the study we want to make on this population. Consider that if we want to sample just 1% of this area, we have to take 400 samples, and that's a lot. Then in order to talk about what is the population, we have to think what parameter we are going to analyze. That is very important, because each parameter has different behavior. Each parameter has its own characteristics, and is going to be distributed spatially in our site in a unique way. And that's the reason, because we have to adapt the population according to the parameter we want to analyze. For example, it's not the same to analyze pH or temperature or electroconductivity, right? Each of these parameters has different gradient, and then we have to consider different kind of populations. For example, when we are doing a survey in a city and we want to know what is the percentage of the population that is consuming a specific brand of beer, we are not going to take all the population of that city. We are not consider the minor people that it's less than 18 years old because they cannot drink alcohol. Then we are going to adapt in that case the population according to the study we want to do, right? Then when we are doing a study in a site that is contaminated, we have to think in the same way. What is the potential population in our site, and what could be the representative samples that we want to take from that population? In addition, we have to think that the soil samples are distributed spatially. It's not just in 2 dimensions like X and Y. The soils are also located at the Z axis. Let me show you in a graph. This one, for example, as you can see, we have here the surface of the terrain, and with Lila we have the sample points. And each of these samples are taken from 0.3 centimeters from the surface, but as you can see, if we take a relative datum, the distance, the depth of the samples are different. It's not the depth of this sample as this one. This one is deeper. And also if we take an absolute datum, the distance are different. And that's something very important to consider, because each of these samples are taken, for example, in a different geological layer, for example, and then we are going to have different results, and it's something really important that has to be considered. Let me show you a different graph, and I'm going to tell you a story. I remember one time listening a group of people talking about the samples they took at the background locations. Background locations is, for example, if you are making a study on a oil and gas field, the background locations is those locations where there was no petroleum activity, and it is supposed the soils are not contaminated in that area. Then what happened in this site was that at the beginning they make one borehole at the background location at a depth of 4 meters, and in that depth they identify impacted soils related with a metal element. Then they made the report and they said that the concentration at that point, it was a natural concentration because the sample was took in a background location where it is supposed there was no petroleum activity. Then when they submit the report to the regulator said, okay, if you want to justify that concentration as a natural value, then you have to pick up different samples in other background locations at the same site to demonstrate that in that depth the geological layer has this metal element with that concentration. Then later they go to the field and they make 2 new boreholes in a different background locations, and they pick up the sample at the same depth for 4 meters from the surface. 4 meters here, also 4 meters here, as they did at the beginning for this sample. And they took the samples at the different locations, they analyzed these samples, and they didn't identify any metal concentration related with that parameter. And then when they submit the report again to the regulator says, okay, if you want to justify that concentration over here, you have to take the samples at the same depth. And they say, I don't understand what the regulator is saying, because we take the samples at the same depth. It was 4 meters, 40 meters, and 4 meters. But they don't consider the depth respect to the absolute datum. The depths, it was different. This one was deeper than this one, and also that this one. And that's the reason, maybe because they didn't identify this metal in these depths, because that ones are close to the surface and maybe we are in a different geological layer. With this history, we can have a better idea how important is the spatial distribution of the samples in our site. However, in this example, we didn't talk about the groundwater, but if there is groundwater, the system even could be more complex, because one contaminant can be moved from one point to a different point according to the groundwater flow direction. But that could be a different topic that can be discussed in another different video. This is the end of this video, and thank you very much for watching, and see you on the next one.